Hi everyone, very good morning. So let's start. I think it is recording. Okay, so fine. So in the last sessions, what we are discussing? So we are discussing about the partitioning, right? So as a Snowflake user, so as we discussed, so we don't have any option to create a partitions. Here it will be automatically the Snowflake will create partitions, and so it will be stored in a blob storage. Every file will be, so it will be in the so compressed form, and then the maximum 16 MB after the compression, right? These are the things what we are discussing. And every partition, so when they partition, so it will maintain a metadata, so for every partition, so that will be the same thing. So here, so if you so observe this, so this one also, the how the partition will happen in the backend. So if you have the data, like what is the partition metadata, how it contains, so this information. And so if you observe the compressed, observe this 52. So without compression, so see, so 50 to 500 MB. After uncompression, it will be maximum 16 MB. And so what it is telling, every partition is immutable. So whenever any updates happening, whenever any inserts happening, so how the partitions will be created. So once the partition is created, so we cannot able to change that partition. We cannot able to so update that partition. If you have any data in this particular partition, if you want to update, so we'll take example and then we will see that how it will be implemented. So this is like so let's see how the partition will be created. Let me show you example here. Let's take this example. So when you are inserting any data, so what will happen? So here, so this is the same example which so the Snowflake has given for us. And if you observe, see this one. So let's consider this data, these six records. Whenever so we are inserting the data into the table. So first time, let's consider this. So P1 and then P2. These are the two partitions it has been created in the backend. So when it's created two partitions, again, so for example, when you are inserting a new record, so when you are inserting so new value Steve, so to this particular partition, so then it will create the new partition P3. It will not disturb the existing partition. It is going to create a new partition. Now observe this, it will be like this. P1 and then P2, and then it is will create a P3 new partition. Suppose, so if you again, so if you delete something, or if you so delete any records, see this one here, so we are trying to delete so one record from the partition one, so this undoes, right? Then it will not disturb this partition, so it will so make this version as a previous version, and the latest version the partition will be P4. Observe this, it is going to create a P4 partition. It will replaces the, see this, the partition P1 and replaces with a new partition P4. So including the changes, right? So every micro partition, so it will be, see this one. So P1, P1, so will be the oldest version, and then P2, P3, P4. So it is not so disturbing the old partition, and then it is creating a new partition. So this way, so how the partition will so create in the backend. So now, so here, so one thing, so we can, so we no need to do anything so far the performance like improvement optimization, how it will happen automatically the micro partition. So here there is a pruning technique. Pruning means, so if you remember, so in the last sessions when we saw the data, let me log into the table. Yeah. So here, see this one. So what is the option here? So this is the total number of partitions, and then this is this partition. So we have so these many number of partitions it has picked. So now when you observe this, so how many partitions it has picked? So in the total number of partitions in 60,000 plus partitions, it has picked 1,524, right? Picking the exact partition, we will call this method as a pruning. We will call this method as a pruning technique. Pruning technique. So that is the same thing. So they are so mentioning here in the optimization. See this one, the static partition pruning based on columns in where condition, and the dynamic partition pruning based on so join columns of a query. So automatically it is going to be so partition, and so best so practice to so this one, so automatically it will filter, and then so it will be natural so clusters, so no need to define anything, automatically it will be applied. The clustering means we have one concept called, okay, for example, let me log into the tool, I will show you what it means by that. When you see our sample database, and then some of the tables we can able to see the cluster by, let's say one is nothing but we can relate it to order by column. Now, just a minute, the worksheet, if you observe this here, see this one, some of the tables you can able to see cluster by, right? Some of the tables you can able to see so cluster by option here. See this one, cluster by, so this one, so income band sk, so cluster by, so demo sk, right? So that is a key. So here, so cluster by column, so some of the tables we don't have the cluster by. The cluster by, so what it will do is it will so automatically it will create, but if you want so any particular table, so based on any specific order it want to save the data, so then nothing but the order by column, so then we have to define a cluster by. Otherwise Snowflake what it will do is automatically it will create, so based on the, so any it will take, so based on the keys, so numeric columns, it is going to create a cluster by, and then it will create a partitions in the backend. So now if you observe so how the things will happen in the backend, let me show you something this, so we will discuss that this is nothing but so the Snowflake partition, so in the backend it will like so create, and pruning, so nothing but like a picking the exact partition, so based on the so minimum and then maximum, so by using metadata. In generally, so in general database we will create any partitions, like for example so hash based or the range based partition, so any one so kind of partition, so we will have a choice, right? We can pick any kind of partition and we'll create a partitions, but here in the Snowflake, so we don't have any option to create a partition. And one more thing is here, overlap depth will be there. Overlap depth is nothing but, let me show you something. So when you come to the clustering concept, you can able to see the clustering, the overlap depth. Now let's observe the same data if it is occupying so in the same space, same partition if it is occupying in the same space, so that is we will call it as a overlap depth. Overlap depth. Now if you observe this here, so we have a records from A to Z. So this one A to Z, so this one, so initially, so first observe this, it's created a partitions like this, and then this is the space where it has been occupied. What it will do is it will this one, when you have the same A to Z records all in one place, this is overlap depth is, so overlapping micro partitions is 5. Observe this, so all the 5 micro partitions it is in the so overlapping same so place. So then so what will so it will do is in the backend, so it will run algorithm, and then it will create until the overlap micro partition depth is 0. Overlap depth we will call it as a 1, and then overlapping micro partitions is 0. So then when you are having this, then this is the until this particular situation, it will keep on run the algorithm in the backend, and then it will create in the partitions in this form. Now if you observe A to D records, and E to Z, E to Z, and then K to N, O to S, and then T to Z. So here we don't have any overlap here. If you observe the above one, this one, see this one here, K to N we have, L to N, in between N to S we have a overlap, and then again here, so Q to Z, so Q to so S, so we have a overlap, right? This is nothing but a so overlap. So initially when it is creating, so it will create a overlaps like this, and then after that, the finally when its partitions is finalized, then it will be the overlap depth will be 1. The overlap micro partitions will be 0. Until this particular position, it will keep on create a micro partitions. Let's observe what is the so mechanism it will run in the backend is. Now if you observe, when the data arrives in any table, so this say this statement, when the data arrives in any table, so it will so split the tables into the levels. So this clustering state, so it will split the tables into levels, and then it will run the clustering partition selection algorithm on each level. So level means nothing but so is this one. So this is the levels. So it will split into the levels, and then it will run so on every so it will run a algorithm on so this so partition. So it is going to like so if you observe this until if your partition depth is see this one not good enough, it will keep on repeating. Not good enough means now observe this. So it is so optimal so non-blocking and then size just right. That is nothing but this particular the overlap depth is 0 or the overlap so micro partition is 0 or overlap depth is 1. So until that particular so time it will keep on running the algorithm in the backend. So once it's achieved that state, then automatically it will sleep. So otherwise it will keep on run the algorithm on that so the data. So any table when it arises. So this is the so what it will do in the backend. So but we cannot do anything so practically, and then so this is not in our control. Automatically a partition will be created, and then so it will automatically so take care of the performance. One thing what we can able to do it here is what we can do is we can create a clusters on a table. Only one thing is so if you observe here, so we have some of the tables so without clusters. These are the huge volume of the data. And if you observe here, some of the tables we have clusters, right? Cluster by, right? Everywhere we can able to see cluster by. This cluster by is nothing but order by data in that particular column. So based on this order by data, so when you are fetching some information, it will fetch the data based on cluster by automatically. So it will when it is loading the data or when it is fetching the data based on this cluster by, it is going to so first it will pick it from the backend. So that is the main intention why they will create cluster by column here. But one more thing, this cluster by so it's a very expensive. So it is not like suggested so for every table. So now let's see that. So what is exactly the cluster by? Let me check. So this one. So when the processing, so data stored in the sorted order along with the natural dimension, then generally it will be in a sort order. The clustering is a key, and then it will query to sort order the data for faster data retrieval. So for faster data retrieval, if you want, we can implement a cluster by. So see this one. So for every table, it is not going to impact it for the cluster. So only the table data is not sorted or only partially sorted. Sorry, impact on the query performance on very large tables. So this one on very large tables only we are going to implement a cluster. So when the data is inserted or loaded into the tables, then clustering metadata is collected and recorded for each micro partition. Observe this statement. So when the data is inserted or loaded into the table, the clustering metadata is collected and recorded for each partition, each micro partition. And using clustering information, the Snowflake avoids unnecessary scanning of the micro partition during query. So what will happen during when you are executing a query, so it will go and then it will scan the micro partitions, right? Again, so when it is scanning micro partition, each and every micro partition, what it will have? It will have a metadata, right? Again, so when you are maintaining a clustering information, so again it will unnecessarily, it will avoid, so and then it will increase the performance. So because based on that particular order, it will store the data and then it will store the metadata. So whatever the key we are giving. And before implementing cluster, so we need to know, so for which column, which key, what is the key column we need to implement a cluster. So based on the requirement, for example, let's say on any table, so what is the most numeric column we are going to so fetch the data frequently. For example, let's say employee id, or so for example, so any any key IDs. It can be a account number or employee ID or Aadhaar number, whatever it may be. So our passport number, whatever it may be. So based on the key columns, so we are going to create a cluster by. If you observe, so this one item SK. So this is a, if you observe the data, here they created the cluster by on item sk. This is a numeric column. Observe this, this is a numeric column. So like this, so based on any numeric column, so on which particular column we are going to fetch the data very frequently. So for that column, we are going to create a cluster by. So but when you are implementing cluster by, we will not implement so by default uh, for every table. It will only useful whenever the table is very huge. It means whenever the table is large table, then only so we will implement the cluster by. Otherwise, we will not implement. Now, so what it will do? So when you implement a cluster again, so it will improve scan efficiency in a queries. And see this one, no additional administration is required. So we don't do anything. Once it's defined a cluster, automatically it is go. So it will take care from the backend. Future maintenance also it will perform automatically. Future maintenance means, so once it is created a cluster here for any column, so futurely when you are like updated, when you inserted some other data also, so no need to do anything, automatically it will take care from the so backend. So based on the key, always when you inserted the data, based on the key, automatically it will add the data and then into the table when it is storing. So this
Dinesh,
all
can you
this in the
provide on multiple columns cluster
yeah,
by?
multiple columns also we can apply. We will implement that. How we can able to implement it in the multiple columns. At the same time, on specific columns also we can apply for the strings also. It means so by using substring function. See this one here, we can able to see cluster by on multiple columns. Two columns we have here. One is return date and then one is another one is item sk, right? So we can able to apply it for the multiple columns also. So now one thing here, so we cannot apply this on every table. So when to define a clustering key, observe this, queries on the table are running slower than expected or have noticeable degrade over the time, so then only we are going to implement a cluster. So clustering, so depth, so for the table is so large. It means a huge volume of the table. So we will implement a cluster by. And one thing, see this one, cluster we can be computationally expensive. So only cluster when the queries will have benefit. So from the clustering. So only for the huge volume of the table and at the same time, so very frequently if you are using the, so when you are fetching the data from the table, then only we will try to implement a so cluster. Otherwise,
Huge,
so we won't
huge,
implement it.
what you
Yeah,
representing from the huge volume?
sorry,
What you representing from the
huge
huge
volume
volume?
of the data.
Because we are already on cloud thing, so we are
Mm-hmm.
expecting that millions of data is a smaller thing for the
Mm,
cloud.
mm, mm, mm.
What we are expecting for the huge means
So more than, let's say, more than 1 TB of the data in the table. If you want to fetch all this mechanism, you can store. There is no limitation in a cloud, as we discussed. There is no limitation. That is true. But when it is coming to command, so when we are fetching any information, let's say you have to fetch the information from this. Let me show you something. Huge tables here. See this one. So we have around TT 1 TB 1.7 terabyte of the data, and then we have around 300 GB of the data, and then we have around 1000 GB of the data here nearly, right? So when you fetch the information from here, so here if you observe, we don't have any cluster by. See this one, we don't have any cluster by. So if you fetch any information from this table, so let's assume that it is taking 10 minutes or 20 minutes. During that 10 minutes or 20 minutes, what will happen? Our processing, the cost will be increased. So based on the virtual warehouse which you are utilizing, right? Let's say, for example, if you implement any cluster on this particular table, so if you have a cluster on any specific column on this table, instead of 10 minutes processing time, so maybe it will give so within 2 minutes or 3 minutes. Then so what we are doing, so we are so reducing the processing charges. So that is the main intention behind so creating a clustering.
Okay, one more thing. Can we put this clustering thing on a clone table? Is this
And a
advice?
clone table,
Is this
no, no,
advice,
no,
sir? Hmm.
no. So we are not going to do that on a clone table. So it's a
Because
base table only.
okay,
Okay. So now, so I will show you so how to create a cluster, and then so what is the so how we can able to do that based on the different columns. Now let's say for example, so we have this example. Try to so fetch some more examples. So in Snowflake documentation. So but so we are having so only this example. So in our Snowflake. So let me show you so how we can able to do that. Now, when we are creating a table, generally what we will do, we will create till here, right? Create or replace a table. So we'll give column name and then data type, column name and data type, column name and then data type. After that, what we will use, so cluster by, observe this, if you want to create a cluster by C1 and C2, column 1 and column 2. So we can create, so only one column, the cluster by, and we can give it for the, so another column also. So let me open the documentation also. So meanwhile, okay. So when you run this, so what will happen? So it will create a table. Now the table is created, and then so where the table is created in our class database. So come to this, fresh it here, class database, and then the table is created. Now observe this cluster by linear. So this is the backend so algorithm what it will so create the cluster by in the mechanism C1 and C2. C1 and C2. C1 and C2 columns are the cluster by. So and so if you show the tables like T1, you can able to see this one cluster by. So if the table is not having any cluster, you can able to see here also. So this one, these tables is not having any cluster by column. So these tables we implemented cluster by column. Now, so for example, so this is for the column 1 and column 2. So if you want specifically, for example, so we can use, so let's assume that we have some account number. In a column, we have a account number. After that, so we have some spaces, or so we'll have some so hyphen. After that, we have name, last name. We have last name itself. Let's assume that in this particular situation, we need to apply only cluster for account number. So let's assume that first 10 digits only I need to create a cluster. This is also possible. So in a particular column, so if you want only the cluster for only account number, so based on the account number only, so it has to enter the data. So that is also possible that we can able to so give the cluster by also. In that particular thing, so what we can do is so we can give the string function like this. Now let's observe this here. Table T2, C1 is a column, C2 is a column, and then C3 is a column. Now if you observe, so cluster by, so this is for the C1 column. So and then substring C2 0 to 10. So first 10 digits is a so account number. Let's assume that. So for first 10 digits only, I need to cluster by, I need to order the data. So then we can so create a substring function like this. then it will be created only so for this particular C2 column and then 0 to 10. Now observe this one. So you can able to see that on a C2 column and then 0 to so 10. So it means so for first 10 digits, so first 10 so characters it is length, so it is going to order the data based on this particular column. For example, this is newly created table, right? So what we are doing, the newly created table. So how we are creating a cluster. Already we have some of the tables here are existing tables. On some of the tables, we don't have a cluster. So if you want to create a cluster for what we can do is alter by. So for example, cluster, the same example I have. So I picked it from here. So let me show you. So this one, so this is the example how we can able to so create a cluster by. So if it is a existing column, then what we can do, so alter table, see this one T1 and then cluster by C1 and C2. So if you so for example, let's assume that so one table is there, so it is taking some time, so like more than like 15 minutes or 20 minutes to fetch the data from the table, so for any specific details. So then so what you can do, if you want to implement, so you have identified that so this particular so table when you are fetching, so every time we are fetching based on some numeric number or any specific column. For that particular column we can pick, and then so we can alter the table and then we can implement a cluster by. We can implement cluster by. Now initially what we have given, we have given for the C1 and C2 here. So if you want to so modify it, so if you want to alter it, you can alter it to the C1 and C3. Then C1 and C2 will be done, and then C1 and C3 will be created the same way. So you can so existing table also we can create a cluster, but this is so generally, so we will not so implement so just like that. So if any like if you observe so any degradable performance, then only they will implement a cluster. So till now, so what, so in my like a project, right? So we will never try to implement a so cluster. So then if it is required, so then only so we'll go with that. So otherwise it is not required. So this is the one, only one thing what you can do to increase the performance in our Snowflake. Other than this, we don't have any other things to improve the performance. Automatically it has to take care from the backend for the so partitions creation, and then so no need to worry about anything from the backend. So only the thing is, so if you want, you can create a cluster. That's it. So that is the so base concept here. So only the cluster partitions will be taken care from the backend. So no need to so worry about that. So I say Snowflake is just we need to understand how the partitions will be created from the backend, how the clustering will work here. So that's it. Okay. So now, so let's see. So next, come to this. Let me show you. Okay. So we'll come to. Okay. So till now, so what we have done. So when you are sorry, when you are working with Snowflake here, when you have loaded any data, if you remember, so in the initial process, so when you are loading a data, what we have done. So we loaded the data by using copy command, right? Okay, so when you loaded the data into the table, so what we have done, so we have so so implemented a copy command so by using so put option, right? So those are all our local files, right? Suppose if your file is available in, so now so next we will see so how to work with a so cloud, how to integrate that. So before that we need to know some terminologies. So what is the so cloud term if you are not having any idea? So don't worry about that. We are not going to do any development in cloud. So just what we are going to do is if the data is available, for example, let's assume that. your data is available in or your files. So generally what we have done, when your file is available in local path, we have loaded to the stage area. Then from the stage, we have copied into the table by using a copy command. This is the thing what we have done. Suppose if your file, whatever the file you are fetching, and then you are loading into the stage by using a put command, if the file is available in a cloud location, it can be AWS or it can be a Azure anywhere. It can be Azure or it can be in a GCP. Any cloud location if it is available. So how we are going to pick the information from the cloud location?
I have a
Here,
hello. Hello.
yes, yes,
Actually,
yeah, yeah, go ahead.
nowadays I can see that few companies are
Mm,
having this cloud thing on in-prem servers.
correct, correct.
So,
Mm.
does
Their
this
own
support?
flow. It is, yeah, yeah. It will support also. Just we are picking. It can be not only these things. Okay, not only these things. It can be any cloud. So let's say you are so. For example, so let's assume IBM is having the own cloud. Oracle also having their own cloud, right? So they are so developing their so things in the own cloud solutions, right? So that is your question, right? So whether we can able to pick the information from there or not, whether we can able to integrate it or not, we can able to do that any cloud. So but so for when you are discussing the example here, so we will see so how to pick the things from so these clouds and then how to integrate it. So now here what we have done, when you are picking the file in so from this particular local path to the stage, we have implemented put command. When you are implementing put command, what we have given, we have given a local path, right? Here what we need to do is we need to know in the cloud location, if it is, let's assume that if it is AWS, we need to know where your file is available, where your file is available, nothing but your cloud path, where your file is available. And another thing is most important thing, the approach, everything will be the same. There is no difference. Like we are going to create a file format, file format, and then we will have a stage area. When it is coming to the cloud, we will call it as a external stages, external stage, external stage. If the file is available in cloud location, call it as a external stage. The name stage we have created, right? The same thing. So we'll call it as a external stage here. So we'll create a stage. After that, we will use a copy command. So this approach will be the same, but only the one thing we need to remember is if file is available in any cloud, it can be AWS or Azure or GCP, any other locate, any other cloud also. If it is like the company's own cloud, like IBM cloud or Oracle cloud, whatever it may be, you need to create integration object. This is main important thing here, integration object. So this one, if you want to communicate with so any other tool, so through Snowflake. So here, so when you observe, so here in a Snowflake, so here we have a data in the tables. These data, so you want to, for example, you want to give this so particular whatever the tables access to any reporting tools like table or power, so Power BI, whatever it may be. Then we need a integration object. Now, so from any ETL, so you need to load the data into this Snowflake tables. You need a integration object. So for example, you need to communicate in between so AWS and Snowflake. You need a integration object. Azure, AWS. So Azure, sorry, Snowflake. You need a integration object. GCP to Snowflake. Anything, any other external so application. Whenever you are going to communicate, we are going to create a integration object. This is the one thing what we need to remember. Once the integration object is created, so we can able to communicate so from so Snowflake to AWS, AWS to Snowflake. So that is so one thing. So we need to work before going to the AWS. If you have so any idea on AWS, that is fine. So if you don't have also, so no issues. Here what we will do is, so I have created one so AWS console account. I will give the same account to you. No need to create. So if you want to create on your own, you can go ahead and you can create. So here is the steps. I will send you so this later. So before going to this, just understand some terminologies here. So wherever we are going to place the files, wherever so the AWS is keep the files, right? We used to call it as a bucket. We used to call it as a bucket. Within the bucket, you will have a folders. You will have folders. Within the folders, you will have files. The same way, so like in our system, if you have a like a drives, within the drives you will have a folder. Within the folders you will have a files, right? Here we used to call it as a bucket where the files is available. That is a bucket. And then for each and every account, so you will have unique ID. Our Snowflake, we have a unique ID, right? See this one, our Snowflake, we have a unique ID, right? So unique ID, this is the unique ID for the Snowflake account. The same way, every AWS account. So let's like discuss the first with the AWS, then it is easy to relate with. So other, the cloud, the platforms also. Now, so when you want to communicate with others, what all the things we required is when you create an integration object, you need to know ARN details. ARN details, user ARN details means nothing but it's a unique the ID, unique account details. So where the AWS contains. Let me show you something here. So when I log into AWS, so here AWS console, AWS console. I will give these details. Just observe this, what all the things is available here. I'm trying to log into AWS console. So in as a Snowflake developer, we are not responsible for this particular thing. So particular AWS or GCP or Azure. So what we need to know is how to create a integration object. You need to know. Let me show you something. AWS steps. The integration object is this is the step. So what we are going to do to create an integration object. When you are creating integration object, see this one. So this details storage role ARN and then allowed location. These details you are going to request so from AWS team. They will give details to us. Based on this, we will create an integration object. That's it. You need to know so where the file is available, that is a storage location, and you need to know so what is the unique so ID for the AWS role. So this is, so if you observe here, let me log in here. So for the practice we are doing everything here. So but in any organization, so you will have a separate team for so AWS. And then so if they are using Azure, it will be a separate team for Azure also, the same way GCP also. If you need any details now, so any other third party, for example reporting guys came, and then if they want to access our Snowflake, what they will do, they will ask, so tell me your the Snowflake account. This is our account details. We will, as a Snowflake the users, we will give this account details to them, right? The same way, if you required any AWS details, what we will ask them, so we will ask the AWS team, so give me your so location details where your file is available, and then so give me the ARN details. These details they will give it to us. Based on this, we are going to create a integration object. So observe this. So what so they are doing, so create or replace storage integration, and this is the integration object. This is main important thing. Once you created this integration object, then only our Snowflake and then AWS both will be communicated, otherwise it will not. If you observe a storage location here, what you observe here, the storage location means where our files is available. Now, if you come to S3, this is a S3 bucket, simple storage services. So IAM means identity and access management. So now here, see this one, this is a bucket. If you want to create a bucket, this is a bucket. This is completely in a cloud. And then within the bucket, what you have, so you have a folders. Within the folder, what you have a file. And so this is the file. So which it is available in our cloud location. Now this file, if you want to see that what it contains, then just click on that and then click on action, and then here query with S3 select. You can able to see the data in the file. So this is completely which is available in a cloud. Now just a minute, run query. Now observe this is a comma delimited file, comma delimited file, right? This is the data in the file. So first line is a column names, right? So where it is available, it is available in this particular path. If you want to copy the path, see this one, so copy S3 URI, so select the file and then copy. So this is the path where your file is available. This is the cloud storage location. See this one, S3 and then colon. If it is available in our local path, so we are giving C and then slash the colons after that path, right? This is S3. This is cloud location wherever. So S3 data is available. This storage location we require. Now, so our requirement is, let's assume that we have a data in the cloud location. We have these files. Now we need to load this into our Snowflake tables. So from where the file is available here. If it is in a local, we are going to use a put command. By connecting through CLI, we will use a put command, it will come. But this is so third party, right? So it means, so we need a permission to access this AWS, right? At the same time, from AWS also, it has to allow the Snowflake to interact with the AWS application, right? It has to pick the data from this location, and then if you observe the role ARN details, role ARN details means for every account, the same way we will have a Snowflake account, right? Here, this is the account. The same way, every cloud account, so they will have the role ARN details. If you observe, this is a unique account ID. See this one. This is the account ID. You will have different roles will available here. To which role? So you need to access. See this one, role ARN. Which role? So you need a access for that particular role. You want to go to that, you can go to, just click on IAM. You will have a number of cloud services in AWS. So we need to know the terminology of only these two things. One is S3 bucket, another one is IAM details. IAM, you can able to see the roles here. Now these are the roles, so which we are having. Now click on the role. So if you click on the role, see this one, this is a role ARN details. This is the role ARN details. This particular role ARN details, and then this particular, so cloud storage location. These two things we required if you want to create a integration object. What it mean by that is, when you are creating integration object, so we are going to, so creating integration, and then we are allowing this particular role to, and then from this particular location, from this role, if it is so sending any particular file, so in this particular path we are allowing it to the Snowflake. That is the meaning of this. So by using this role, so if you use, so if you send any specific files from this particular, exactly from this location, then it is going to, so allow, the Snowflake will allow. The Snowflake, we are creating integration object, but the same way, so from the AWS also, it has to like allow the Snowflake, right? The Snowflake is allowing this role and then this particular path. But what about the AWS? For that only we are creating a integration object. Now let's observe this here. So I'm not sure whether it will the role. So let's try this. Otherwise, again, we will see that in the next session how to do that exactly. Now see this one, integration object is created. So when we are creating, when we are trying to create integration object, what are the details we are giving? One is role ARN, one is a role ARN details. So for the Snowflake, sorry, AWS role, and then another one is storage location. When you give these details, when you create an integration object, now integration object is created. When you describe integration, so what is the integration name? S3INT. This is the same approach for every cloud, every cloud. Now observe this. This integration object, what it is generated is, if you observe, see this one, external ID, external ID. This is the external ID it has generated. So now our Snowflake has generated these details, right? This is the external ID. Another thing is user ARN. User ARN. Let's try to understand this, why it is required. This is a user ARN. User ARN means, so here we are allowing, so our AWS to communicate with Snowflake. The same way AWS also has to allow Snowflake to communicate, right? For that, see this one, this is the external ID. External ID means, so based on every every user account, so every account, so you, it will communicate, it will give a, now observe the account ID here. See this one, this is my account. Observe the account here, IQ02405, right? This is account. This external ID, it is generated for this particular Snowflake account. And at the same time, so what is the user here? So my user is, so this one, Snowflake, so 7, right? And here if you observe, the same way user ARN, it has generated for this particular user. So whatever the user I am using, so for this user, see this one, so for this particular user, it has generated this unique details. These unique details you are going to update, you are going to, so update in AWS. We will, these details has been generated by Snowflake when you create an integration object. So this one, if you want to communicate and then AWS has to allow, then you need to give this account details to AWS and then this user details to the AWS. So that is the meaning of these details. So you will give it to AWS team. So and then they will update these details in, observe this, for this particular role, trusted relationship policy. See this one, trusted relationship. They will come here and then they will click on edit trusted relationship, and then whatever the user details it has generated, they will give the user details here and then it will be updated, and then they will give the external ID here. So let me show you. So this is the external ID. So this external ID we are going to give it here, and then this is the user details. This is the user details we are going to give it here. Once you given these details to AWS, once they updated the detail for that particular role, then update the details. Now so this, it's updated. Then this role will allow our Snowflake user and then this particular account and then this user to access this particular location and then this particular role. In the both the ways we are giving the communication, we are creating a integration object. So this integration object, when you want to create the integration object, what are the details we required? We required a role ARN. This is for the specific role. This is for the allowed storage location wherever files is available. Once you create the integration object, then it will generate these two details. One is the external ID, another one is, so another one is the user ARN details. This is role ARN details. This is user ARN details for our user, our Snowflake user. These details where, so they have to update, they have to update that in a trusted relationship policy. Once they have updated, so then, so both the thing will communicate. Once this integration object is created and these details has been updated, then only we can create a stage. We can create a external stage. Otherwise, it is not possible. If you try to pick the data from this particular location without integration object, it will not allow you to, so pick the information from this location. So by using this role, it is not possible. So that's why integration objects need to be created. Once the integration object created, we will update these details. Once you update these details, then we can able to access that. So these are the high level, so what, so we used to like a work. So most of the time, so frequently when if it is AWS or if it is a Azure, So here we will call it as a bucket, right? This one S3 bucket. In a Azure, we will call it as a mm, this one container. Okay, so or so bucket. So where the storage location, there also we'll call it as a IAM, identity and access management. There is no difference. Approach will be the same. Any integration when you want to create the same thing. So any integration we can able to create it here. But what we required, so with which application we are creating an integration object, that we need to know. Based on that, here we are giving the AWS details because this is a storage AWS details, right? So this storage location also AWS. Here instead of AWS, if it is a Azure, we will give Azure details here, Azure ID details, and then storage location from the Azure. That's it. That is the only one change. Remaining everything will be the common integration object. After the integration object, so we are going to so create a file format, external stage. After that we will use a copy command. When you are working with this, so not only so only with the CSV files we will see that, so how to work with the semi structured files also, Parquet files and then JSON files also we will see. So if you observe in this particular the cloud location, so where we are having in this particular bucket, you can able to see the Parquet files, and then those are the semi-structured files. So now if you observe in this, these are the JSON and then Parquet are the semi-structured files. So these files will be in the form of variant data type. We will see that how to deal with a JSON files, how to deal with the Parquet files also when you are loading the data into our Snowflake. But approach will be the same. Okay, so what we need to know before creating an integration object, we need to know the user ARN details and then the path we required. Once created integration object, we will give the whatever the details generated by our Snowflake, we will give it to the Snowflake team. They are going to update it in IAM trusted relationship policy. These are the additional steps what we are going to implement when we are communicating with the cloud partners. It can be anything. Okay, the approach will be the same. There is no difference. We will see that practically. So we will pick a file and then we will upload it into our the Snowflake tables. So by using this integration in the next sessions. Okay, so any questions here? Can see.
Dinesh, I mean, in normal scenarios, I mean, traditional database, like it's like a cataloging. In integration, nothing
Mm-hmm.
but right?
Mm, yeah.
Dinesh, can you please go back to your screen once? There you have taken the
Sure.
details like roll number, right? So from where
Correct.
you told us that from Snowflake team you will get those details, right? So
Yeah, to as a Snowflake team, we will ask the AWS team to give the so role ARN details.
okay,
This one, role ARN details, and then this location. They will provide these details to us. So those
and
details you can be able to see that in IAM. Okay. So this role, the specifically for the role. This is for the specific role
okay,
here.
from
So
here
this
you
one role.
copy those role ARN number,
Exactly. This is the role ARN.
and along with this role ARN below there are two details you have
Hmm.
picked up, right? So from where you have picked this?
These details. So once we create this integration object, right? This
Hmm.
integration. So based
Yes.
on these details, it will generate these details for the integration object. Now observe this. Integration object is created. So once
Okay.
integration object created, describe integration. When you describe integration, you can able to see this one. This is the allowed location which you have given, right?
Okay.
So
Okay.
when we have created an integration object, this is the user ARN and then role ARN. For this role, we have created for this particular location. When we have created the integration for this role and then for this location, it has generated this user ARN details, and then this is for the external ID for the our Snowflake account. This details and then these details, again we will give it to the AWS team, these details to
Okay.
update in the account. Okay, for
Yes.
this is
Got it.
trusted relationship policy, they will update. That's it.
Got it.
So once they have done, then only integration will be created. Okay, good.
Okay. Yeah. Dinesh, I have one query. That
Yes,
this
Kumar.
query is yesterday I talked about the query execution plan. Does this Snowflake stores this query execution plan somewhere?
Yes, in a query ID. So it will be the execution plan. You can able to see one for 14 days in the history. You have a
Uh,
history tab, right? In the history tab, if you click on any query ID, so it will show you in the backend. So what is happening? If you run any huge query also, you can able to see that the complete execution plan here in the profile.
uh, and
With
any
kind of
objective
log.
information, information schema,
Mm, objective.
any object in information schema which provides these details.
Okay, you are talking about in information schema.
Uh,
Uh, it's related to, for example, if it is related to the stage, it will be available in a stage details. Okay, if it is related to so history, you can check history. Okay, so you will get all this information from there.
but if this is providing that execution plan, then it must be somewhere storing.
Yeah, that is information schema in history.
Okay. And
History object.
how this get flushed in the sequential fashion, or what means
Uh,
uh,
Based on the date. Yeah,
only on the date.
only on the date.
Okay.
So generally what we will do is so it will flush and so it will flush right all the history. So in general, any like a traditional mechanism, what they will do is to capture all this information. If they want, they will create a audit files, audit tables. Then audit tables, they will keep this information. So which table the data has been loaded. So by using which pipe. So pipe we are going to discuss in the next sessions. Using which task, all these details will be available in the audit table. So permanently, if you want to keep these details there, if you want to trace it back, that is the one option.
Okay. So will you discuss about audit in future? Means
We
next
will see
classes?
that.
Okay.
We'll see that.
And when I talk about this cloud integration and all that which we are doing
Mm,
through AWS,
mm,
so I think it is
mm,
exposed on internet. So how
Correct.
we are means this is Snowflake, or we have to take care about this
Mm,
security thing.
mm. Security, so no need to worry about that. So because here that's why, so that is a main reason. So we are creating an integration object here, right? So
Hmm.
without integration object, we cannot able to do anything. Again, so once we create a integration from the Snowflake again, so we need again the additional confirmation from AWS also, right? So here that's why they are updating this trusted relationship policies there. So once they are updated, then only we can able to communicate. Otherwise, it is not possible.
Actually,
So it's completely
few,
secure. Mm,
few days back we had a application installed on AWS, and due
mm-hmm.
to our weak password, it got hacked. Right. So that's why I'm
Okay.
asking this thing. Yeah, does this
Mhm.
also be means kind of means hackable, or means
No,
how
no, no,
this?
it's not. It will not be. It will not be. Okay, so no
Okay.
need to worry about it. So this is like a levels of security levels. So we are updating here. So this trusted relationship policy is updating. So that too only for the role. So if you observe, so not for the complete account we are doing that. Only for the role only we are implementing it.
Okay.
Okay, any other questions?
Uh, uh, I'm just asking one question out of the box.
Yeah, Kumar.
See, there are cloud on the in-prem.
Mm-hmm,
Means in my
mm-hmm.
organization, it is also there.
Understand.
Uh,
Understand. Okay. Mm,
but means what is the benefit of
mm,
in-prem cloud? Which like the resource, the hardware and the servers and the memory, everything is from our side. So how we are
mm,
getting
mm.
that feature of cloud? How we are calling them as a cloud? This is what I am
Mm.
able to not able to understand.
And understand. I will give you a simple example. For
Okay.
example, when your organization is using your own cloud environment, if you go to any Snowflake, any AWS platform, what all the things they will provide? They will provide a database, the storage, and then they will provide EC2 instances like computation, right? And
Mm-hmm.
then they will provide so additional like services. So let's say if you observe in Snowflake, you will have all these other services. See this one, all these other containers, computation, and then like a database, and then so other like a development tools. All this will be available in the yet this is AWS platform, right? To utilize these AWS platform, so they will charge something from your organization, right?
Mm-hmm.
What they will do is instead of like approaching AWS, so for the platform, so the nowadays some companies they are coming with their own cloud solution. Whatever the application related to their organization, so those applications, all the services will be they will kept it in the complete cloud.
Mm-hmm.
Let's say it can be a storage, it can be a computation, so it can be any other like internal tools. Suppose let's assume that some of the companies have developed some of the internal tools for the let's say data transfer or any other like a reporting purpose or whatever it may be. All these tools, so they need to so give the access to all the like organization, right? Anyone if it is required, then again no need to install and then no need to implement everything from the so starting, right? Everything is available in the cloud, so they can use the cloud. It's like centrally they are maintaining all the applications at the same time all the storage. So that is a so difference. And
So they will.
again there is a
Mm.
challenge, there is a challenge also again. If the company is having their own cloud, again if they want to interact with like AWS platform or Azure platform, so the communication in between again they need to uh, so connect. So that is so one extra thing they have to take care.
Okay. And so they will be not charging for this compute thing and all that. They are just charging for this
No. Mm.
cost of the
Utilization.
tool they are using, right? Hello?
Exactly.
They are not charging for
Exactly. That is
compute thing. Let's say I have
that is
queried and it took 2 credit, then they will not charge for
Mhm.
2 credit, but they will charge for usage of the tool, and that will be fixed thing,
Yes.
right? That
Yes.
okay, okay. So if you can give me some detail of this in just for future perspective,
Sure. Sure. We will
because
discuss.
uh, we may have many of us may have good experience, then it may be
Okay.
required to set up.
Yeah, yeah, definitely. We will see that so with the Azure platform and the GCP platform also, the same approach we are going to implement it. And then we will see how to integrate with Python also in the so further sessions. Then you will get one idea how we can connect with the Snowflake to other communications.
And how this will be good if you start pipeline before the cloud and all
Okay.
that. Because this is very means used thing.
Mm,
I have seen this,
okay.
so it
Mm,
all it may require more hands on this part.
mm. We are
So
going to implement it. So from the next class onwards, we are going to implement this same thing. Once it is completed, all these things are the advanced topics. Okay, we will discuss one by one.
I was thinking that snow pipe, if you can take earlier before going into other thing.
These things. Yeah, yeah. So this without before understanding of these things, right? If you go to Snowpipe, so the guys will so cannot able to understand the
Okay,
things. Okay, that's
okay,
why.
okay,
So it is
okay,
important.
okay,
So
okay.
first, if you discuss so what is AWS, how to communicate with the AWS, then we can know that how to integrate. So how to like give the automation in continuous ingestion by using AWS. Then we will
Mhm.
understand that. Okay, that's right.
Okay,
It is simple concept only. Okay, so you can understand very easily. Don't worry about that. Okay,
okay.
I will take care of those things. Okay, thank you everyone.
Yeah,
So we'll
Dinesh,
see you
in that
on.
in that
Something English. Yeah.
things you have
Yes, sir.
mentioned, right? The list. Do
Yeah.
we cover all the real time topics which we use
Mm.
and the interview related things, or will we
Exactly.
missing any
Exactly.
concepts in that list actually? Because
No,
we
no. So
don't
we are
know
not.
about much about Snowflake. So
Understand.
whatever your
I understand.
uh,
Mhm. So whatever the things we are having, right? Almost all the functionality in Snowflake. So we are covering and all the advanced topics also. Okay. So don't worry about that. We are covering everything. So sometimes what will happen is, so when any organization, so they may so have their own like requirements, right? In that particular situation, if you want, if you feel that in this topic, if you have any, if you need any guidance, so let me know, we will discuss on that. So once the classes is completed, it may not required for so everyone, right?
yeah.
Okay, we will discuss separately.
And other
Okay,
than
don't
that,
worry. And
here
then
your
certification we are
mm,
covering, and then I will send you the certification dumps as well.
and in
When
this
can when we are sharing that certification dump and interview questions and all that?
So if we are planning for the certification, let me know. Generally, I will share the certification dumps. So once the like all this syllabus is completed. So if you
No,
want,
no,
let me know. So I will share it to you.
you can share so that we could get a chance to start in the thing
Sure,
in
definitely.
in parallel, right? And also the
Sure,
interview
sure.
question.
Yeah, sure.
yeah,
Okay, I will do that.
one more thing, Dinesh, in that list there are like AWS, GCP, Azure, everything. But how to connect to
Mm-hmm.
database or something other partner like Informatica Cloud or Metalink. So
Ah,
if you
ah.
cover one or two more options also, that will be helpful
Sure,
because
sure, sir. That is
most
very, very simple. Yeah, yeah, simple
uh,
thing. There is no, there is not much. If you observe the partner connect, right?
mm,
Here we have already it's inbuilt it. So just you need to click and then you need to so like so click, click, click. Automatically it will generate a connection between. So for example, if you want to use Informatica, it will connect, give the like a DB connection. Generally, when we are loading from any ETL tool to database, what we will do, we will create a database connectivities, right? These connections will be automatically created. If you use Matillion ETL tool, so then automatically it will create. So no need to do anything, any setup from the backend. I will show you.
yeah,
So
I
I'm
know
so
it's difficult to explain each and every partner, but maybe
correct.
the frequent top three
I will
frequently
see
used.
that.
Like, yeah.
I will so try this Matillion and then I will try to implement that.
Mm,
Okay, we will see that one.
mm, yeah.
So it does not have direct connectivity with Oracle and all the database to
No,
database.
no, we don't have any direct connectivity. We need a integration.
Can we do it through Python and all that? Maybe Python
We
scripting
can
may.
do that.
Oh,
Yes, yes, that is possible.
okay.
Yeah, for that database, please cover while you're explaining in doing Python, just how to connect and without
Yeah, I
Python
will see that.
also, yeah, without Python also,
Mm-hmm.
how we need to connect, like maybe like ODBC connections like that. Please explain that also.
Mm-hmm.
Yeah. Yeah.
Sure, 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 sir.
Do you
Okay.
suggest any ETL
Thank
tool?
you.
Because 5 years back I worked on Informatica. I don't have much idea
Mm-hmm.
now.
Mm-hmm.
I'm just revising. So is there any trending
Okay.
ETL tool for now which we can?
You can check for, especially when it is coming to Snowflake integration, Matillion is the one so which is frequently using.
Okay, Matillion and Snowflake combination will be good. That's what.
Yes.
Yeah.
Correct,
Okay.
correct.
Okay. Yeah, refer anyone who is providing Matillion training. Yeah.
I have to check Sarwan on this.
Okay.
Okay, I will
Okay.
check and get back to you. Okay.
Okay. Yeah.
No,
Thank
I
you.
know one guy who is working on Matillion. I will check with him and then I will get
Okay.
let you know.
Yeah.
Okay.
Thank you.
And Dinesh, one thing I'm very much
Yes.
curious that
Mm-hmm.
what is the demand of the resources in Snowflake? Like
Mm-hmm.
say I'm having around 20 year of experience, 19, 20 year,
Mm-hmm.
and sure
Mm-hmm.
it is for sure that the companies is not going to hire me as a developer.
Mm-hmm.
So
Definitely for Snowflake solution architect or uh, yeah.
yeah, so means
Mm.
how means how many persons are generally in the team, and what are all the requirements of the team?
Mm, mm,
I want
mm.
to understand about all these things.
Sure, sure, Kumar. Definitely, I will guide you on this. So connect separately for this particular session. I will explain you. So before doing the marketing of your resume,
Mm-hmm.
okay, uh, how to explain the project. So how to like a project yourself. So as a Snowflake solution architect, what are the things you have done? So what are the implementation you have implemented? How many members in it? Generally it will be depends on the project. Obviously it will be
Mm-hmm.
around 30 to 40 members will be there. It depends on the project. And then so what exactly we are doing. Okay, normally any ETL and the data warehousing projects, so you will have a ETL team, you will have a database team, you will have a scripting team, you will have a scheduling team, right? All this together we can call it as a warehouse team, right?
Mm-hmm.
So any project, the same way here also, there is no difference. So only in place of, let's assume that in traditional things we are using a Oracle database. So, but here in place of Oracle we are using Snowflake, or in place of Teradata we are using Snowflake here.
Mm. So is this
That,
means Snowflake is planning to go future for go for LOP OLAP in future?
they are planning for that, Kumar. If you observe here,
Oh,
one
sorry,
thing in
OLTP in future.
reporting, right? Yeah, I
Not for
understand.
reporting, for the transactional
Mhm.
database, like production instance.
Transitional things, not immediately. So what they are telling this, they are planning for this one reporting purpose, or OLAP. Okay. So this
Oh.
is now it is meant for you can consider ELD, extract and then load.
Mm. And
If
what is the
any requirement.
transformation logic? Where we do the transformation logic means
So that will
because
use any ETL tools.
okay. But I have
Mm.
studied that it also have that transformation features, because we have learned about
Not
extract and load, but we have not.
correct, correct. Not much transformation switches here, Kumar. Because
Mhm,
so we saw that so just took truncate options and then validate options. All these things we can able to do, right? So that
mhm.
is the only the thing. If you want the more transformations logics, then we need to implement that in Python, or we need to do that in a JavaScript.
Okay,
There
through
are any
functions.
ETL.
Okay,
Yes, exactly. Or any of the ETL tool here.
okay.
For
So
exactly for the
they
business.
will take the data from Snowflake and then push the data into Snowflake.
Correct, exactly. So it can be so different also. They will take the data from Oracle so source, and then they will put the data into Snowflake also. In between, you will have a ETL tools,
Mhm.
or they will take the data from a AWS file system, and then they will keep the data into. They will transform the data in so any ETL tool, and then they will finally keep the data into our Snowflake tables. It will
Mhm.
be like that.
Okay. So when can you give me your time? Means
We'll plan that commodity next week. Next weekend, we will see that. Okay.
okay, 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 okay. Thanks.
Dinesh, one last question. So, as
Arun,
whatever you are saying, what you are explaining, so we are practicing the same. So, are
mm,
there any complex queries we need to be practiced when we get ready for the interview? So, is it
uh,
sufficient or is there
honestly,
anything extra we
this
need
is
to
this
learn?
is this is more than sufficient, Arvind. So whatever we are practicing, right? Whatever we are explaining, you can tell the same thing. So we are explaining the roles and responsibilities, right? So what is our
Okay.
work? What exactly we are doing? We can explain the same thing. That is more than sufficient.
So, whatever the scenarios you are covering, so these are the only scenarios we are going to use in the project. So,
Exactly.
not beyond this, any like scenario not going to be working
We
on the
will not.
project. So all the topics
Exactly.
you are covering mostly.
Yes, Arvind.
Okay. Thank you so much.
Yeah. Thank you. Okay. Yes. Thank you, everyone. So see you on Monday.
Yeah. Thanks,
Happy
Dinesh.
weekend. Happy
Yeah,
New
thank
Advance
you,
Year.
Dinesh,
Happy
for
New
your
Year.
time.
Happy New Year to everyone.
Wish you happy new year all.
Yeah. Thank you. Wish you same. Yeah.
Yeah, thank you.
Thank you all.